Around late 2019, Pytorch announced Pytorch-XLA, a Pytorch project, which enables Pytorch models to run on TPUs. Our goal is to enable fast AI to run on TPUs using Pytorch-XLA.
We teamed up in June 27 after Roach posted a link to the Pytorch Summer Hackathon 2020 in fast.ai forums. So here we are, 2 months later, still at it.
Here's the project TLDR. It's easy to use. Building it was initially easy, but now that we're going deeper, there are some issues. It's definitely not done yet, but as a hackathon project, David and I can definitely say we've learned a lot and it's been lots of fun.
Fast.ai is a high-level deep learning library built on top of Pytorch. It incorporates the latest deep learning algorithms for computer vision, LMP, tabular and collaborative filtering. But currently it doesn't run on TPUs. Our goal is simple: enable TPU support for fastai using Pytorch-XLA library.
Currently, the free tiers of Colab and Kaggle only support a single GPU, but allow up to 8 TPU cores. Also, the paid tiers of GCP, the Google Cloud Platform, allows for more TPU cores. We want to enable beginners, researchers, and Kaggle competitors to use FastAI's cutting-edge techniques such as discriminative learning rates and one-cycle training while availing of more powerful processors. We also want to be able to shift from GPUs to TPUs and vice versa very easily.
MBDF is a literary programming system that allows us to use Jupyter notebooks to test and document our library as we are building it. It also allows us to run the notebook test in a continuous integration system like GitHub Actions, as well as rebuild our documentation share for notebooks. It also builds the Python package that you can pip install normally.
This is our documentation site. It's based on the same Jupyter notebooks that builds the Python package library, which is why it's easy to keep our documentation updated. It's also easy to check if our documentation is up to date because it's also executable as Jupyter notebooks.
Just add one line to an existing fastai notebook and everything else is taken care of behind the scenes.
For a short demo on how to use our package, we will be running Jupyter notebooks. We are running one such notebook now. These are basic fastai notebooks with the additional pip install of Pytorch-XLA libraries in our package. With the addition of one line to import the fastai XLA Extensions library. We just run normal training steps, downloading the MNIST dataset, configuring the data loaders, and creating the model trainer, and then running fine-tune to do the training. As you might notice, we only had to change one line of the code, and everything is still running the same way. This is one of our goals in the project, to make it easy for people to shift back and forth between GPUs and TPUs. As you can see, it's training now, running the fine-tune and getting a very high accuracy. This is just normal fastai notebooks. And you can also see all the other tricks that fastai implements, such as the learning rate finder. Also shows you how to fit one cycle, which uses discriminative learning rates. And then we can save our models just like normal Pytorch models. And you can also see that we are running normal fastai notebooks.
We are still in the early stage of development, but we have big plans for this project beyond the hackathon. There's still a lot of work to be done and the underlying fastai library is also quickly evolving, so we plan to keep working on this.
We are still working on bugs and performance optimization. We are also in the early stages of studying how to support multiple TPU cores and multiprocessing. We are looking to apply fast.ai to use transfer learning on larger models, such as Hugging Face transformer models. We've been reporting missing XLA instructions for lowering to the Pytorch-XLA team.
Because fastai use a lot of the latest deep learning techniques, we have been working with Pytorch-XLA team to make sure Pytorch supports the TPU well. If fastai can support multiple TPU cores, more Kaggle competitions will definitely use it in competitions. Training will definitely run faster and will have better support for bigger batch sizes and bigger models. We believe there is a lot of potential for this project.
From the Philippines and from Mexico, muchas gracias and mabuhay.